Hey everyone, in this lesson we are going to be looking at generating our mesh. Now we're not going to be adding in the hills and valleys of our terrain, but what we are going to do is generate the base mesh so that in the future we can then start to modify it by adding in hills and valleys just like I said. So how are we going to generate a brand new mesh from scratch inside of our Godot script? Well, we're going to be utilizing three different properties that we can of course modify throughout our project, and these are going to be size width, size depth, and mesh resolution. So first thing we're going to do is generate a basic square plane mesh like this with any arbitrary size, let's just say 20 by 20 meters. Then in order to actually modify this mesh, adding in hills and that, we need to subdivide it a number of times, okay? And this is going to involve adding in 20 subdivisions like this, because as you can see, this is a 20 by 20 grid, 20 by 20 mesh. So every meter, we are basically going to have a brand new subdivision. And then each of these vertices, all these different points, are going to be the things that we are going to modify. Now, you may notice that if we are having each vertice 1 meter apart, then when it comes down to having very jagged terrain, it's not going to look that good, okay? It's going to be pretty blocky. So what we can then do is increase the mesh resolution by adding in even more subdivisions. And this is where that mesh resolution variable comes into play, that property. Pretty much the mesh resolution is just going to be multiplied by the width and the depth to determine the subdivisions. So at 1, that is just going to be 20 on each side. 2, that is going to be 40, okay, 20 times 2. And then 3 is going to be 60. So you can see the higher we set our mesh resolution, the more dense these vertices are going to be. So the smoother our terrain is going to look, and it's going to probably also be a bit nicer for the player to walk on as well. But of course, that means much more vertices, more triangles, more processing time, and more rendering time as well. So let's jump in and look at how we can actually set this up. So here inside of Godot, what we're going to do is we're going to start off by creating a brand new node, and this is just going to be your base node right here. We're going to rename this to be terrain generation. And then we want to also go down to our procedural generation folder, right click on that, and create a new script called terrain generation. Okay, we can then attach it to that node and then open it up inside of the editor right here. Okay, so the first thing we're going to do is we are going to delete the process function since we are not going to be needing it. We are going to be using the ready function though, so we'll just leave that for now. And then up here, we are going to give our script a class name. So class name of terrain generation. So if we wanted to reference it in other scripts, we can easily do that. And then we need to create some variables. So the first variable is going to be our mesh, which is going to be of type mesh instance 3D. Now we aren't going to be creating a mesh instance 3D node because this is going to be spawned in and generated inside of this script. Okay, this variable is just going to be holding onto that mesh, so if we need it later on, we can easily access it. Then we're going to have another variable. This one is going to be for our size depth, and this is going to be basically how long our mesh is going to be in terms of meters or Godot units. So we'll just have that at 100 for now, and it's also going to be of type int. So we'll make sure to do that as well. And then we also then want size width, which is going to be the other side, int as well, and this is going to be equal to 102. Then we need our mesh resolution. So we'll create a mesh resolution variable of type int, and we'll have that to be set to 2 right now. So this basically means every half meter there is going to be a subdivision. Next, what we need to do is we need to then actually generate this mesh. So for this, we're going to create a new function called generate, and we'll set that to be pass for now because inside of ready, we're going to call generate. Okay. So down inside this generate function, the first thing we need to do is actually generate our plane mesh. This is just going to basically generate in the data that we're going to have for our mesh. So for this, I'm going to create a variable called plane mesh, and this is going to be equal to plane mesh dot new. And a plane is basically just a flat square mesh, okay, as simple as it can get. Then we need to set the size of it, okay? How big is it going to be? Is it going to be a meter long? Is it going to be 1,000 meters? So we're going to go plain mesh dot size equals, and this is a vector 2, so it has an x and a y, a width and a depth. So we'll go size width and size depth. Then we need to determine the subdivisions, okay? So this is basically how many times are we going to slice it along its depth and how many times are we going to slice it along its width, okay? So this is adding in those new vertices for us to then modify. So we'll go plain mesh dot subdivide width, we'll go subdivide depth equals our size depth multiplied by the mesh resolution. And then we can do the same thing for the subdivide width. So plain mesh dot subdivide width equals size width multiplied by mesh resolution. Now this here isn't actually our mesh per se, this is more so the data that we are creating, okay? We're giving it the information it needs to then generate the mesh. So the next step is going to be giving it a material, okay? Now if we go down to our procedural generation materials folder, you'll notice we have a terrain material right here, which I've already gone ahead and created, okay? So we're going to assign that by going plain mesh dot material equals preload, and then we just want to go down here and search for that terrain material dot tres right there, okay? There we go. Now that we have all that, the next step is going to be actually generating the mesh from the given data. So for this, we need a surface tool, okay? And this is basically a tool in Godot that allows us to construct a mesh from the given data. So I'll create a variable here called surface, and this is going to be equal to surface tool.new. Now, what are we doing with this surface tool? Well, pretty much we are going to be creating our mesh from the given plain mesh data up here. Now to do this, all we need to do is just go surface dot create from, and then we send over our mesh. So we'll go plain mesh, and then we also need to give it a surface ID. So we'll just go 0. This is pretty much just boilerplate stuff, so don't worry too much about that number. Then what we need to do is we, of course, then need to actually then create the node, because this isn't creating a node. This is just creating a mesh resource that we then need to apply to our mesh node. So for this, what we're going to do is we are going to create a new mesh. So we'll go mesh, which is referencing this variable here, our mesh instance 3D, is going to be equal to a mesh instance 3D.new. Okay, so this is creating that mesh instance 3D node. We can then give it our mesh, so go mesh.mesh equals surface.commit. Now, surface.commit, this basically then generates the final mesh, okay? Then what we can do is we can go mesh.create tri-mesh collision. This is going to create the collider for our terrain. We then want to determine the shadow settings, so we'll go mesh.cast shadow equals geometry instance 3D, and we want to go shadow casting setting off. And the next step is going to be adding it to the group called nav source. Now this is for later on when we start generating our nav mesh. So we'll just go mesh.add to group, and then we'll go nav source. Okay, this is optional if you want navigation on your terrain. And then finally add child, because we of course want to add this to the tree mesh. So this code here should have us set up to generate a flat 2D plane with that given material. So if I go back into 3D mode here, I'm going to go ahead and create a new camera 3D node. We can then move this over here, rotate it down a bit, move it up, save that, set that as current, press play, and we should then see our mesh right here. Now let's add in a light and some skybox. So up here, I'm going to click on these 3 little dots, and I'm going to click add sun to scene and also add environment to scene. Let's move the camera up as well a bit so we can see it a bit better. There we go. Press play, and there is our terrain. Okay, in fact, let's move the camera down a tiny bit more so we can get a better view of the entire thing. And let's actually then move it up like that. And there we go. So we got our terrain set up. Now the next step is going to be the process of modifying the height of each vertice so that we can have our terrain. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be looking at how we can begin to shape our terrain, because right now it is just a flat square and we want to give it hills, valleys, we want to give it cliffs. So how can we actually do that? Well, we're going to do this with noise. Now, you may have seen noise before, okay? It looks a bit like TV static. You may have heard of Perlin noise before. Basically, this is it can be represented as a texture here, but it is basically a formula that we can give an X and a Y position to, and it will return to us a value between 0 and 1. And with this, we can then start shaping our terrain. So, you may have seen this before, represented as this black and white image. You can see how it smoothly transitions between black and white, black being 0, white being 1. And what we're going to do is basically, okay, we have our terrain here, which is basically a grid of vertices, all right, all the individual points. Now, for each of these points, we are going to basically get it, and we are going to get its X and Y position and feed it into the noise algorithm, which is then going to sample a position on the noise map and return to us a value between 0 and 1. And using that 0 and 1, we'll then multiply that by another number in order to get that vertice's Y position. So we'll then move it up a bit, we'll get the vertice next to it, move that one up a bit, maybe a bit different than the one to its left, and overall our terrain will then begin to be taking shape. So this is basically us combining our mesh grid here with the noise map in order to create our terrain. So let's jump in and actually look at how we can set this up. Okay, so in Godot, we're going to hop over back to our script here, and what we're going to do is we're going to create a few new variables. Let's go down here, and the first variable we are going to create is a variable for our noise. So I'm going to create a variable called noise, and this is going to be of type fast noise light. Now, let's also add the export tag here, so that is exported like so. And this noise variable, if we click on our terrain generation node, you'll notice that it is a property, so we can click on it, create a new fast noise light, and if I open it up, you'll notice we get this noise texture right here. Now this is basically the noise we are going to be working with, okay? So you can see it goes from black to white, 0 to 1, and we can then sample an X and a Y coordinate on this noise map in order to get one of those values. Now down here we have a bunch of different settings, such as the noise type, which we can change here. We have the seed, so this is going to basically be what we randomly set at the start of the game to change our terrain, so it's random each time. The frequency basically determines how zoomed into the noise map we are. A high frequency will have much more jagged terrain, while a lower one will have smoother hills. And then we have an offset and some other properties as well that we can modify, but we're going to keep this pretty much at default for now. So let's actually have a look at how we can apply this to our mesh. Now, back inside of our script, in order to apply this noise map to our terrain, we first of all need to be able to have access to each of our individual vertices. And for this, if we scroll down here, we are going to need a new tool. So I'm going to create a variable here called data, and this is going to equal our mesh data tool.new. Now, our mesh data tool is basically what we use in order to access and edit the individual vertices of our plane. So, to do this, what we're then going to do is we're going to go down to a new line here, and we then need to create a variable called array plane, and this is basically going to be an array of all the vertices in our mesh, and this is going to be equal to surface.commit. And we then need to basically apply this to our mesh data tool so we can start using it. And for this, we're going to go data.create from surface, sending over our array plane and a surface ID of just 0. Okay. Now, the next step is going to be looping through each of our vertices with a for loop and then modifying the vertice position. So for this, we're going to create a for loop for I in range, and the range is going to be data.getVertexCount. Okay, so this is going to get the number of vertices, and we're going to loop through that. Then for each vertice, we first of all want to get the vertex. So vertex equals data.getVertexI. Now, for testing purposes, to make sure it works, let's modify the vertex's Y position. So we'll go vertex.y, and for this, we'll just go randf_range between 0 and 10, okay, just for testing purposes. Then we need to go data.setVertex. So we basically need to apply these changes. We'll give it the vertex ID, and then we give it the vertex, okay, and there we go. Now, after that, what we need to do is we need to clear our array plane. So we'll go array plane dot clear surfaces, not clear blend shapes, clear surfaces. Then we need to commit this array plane to our data tool again. So we'll go data.commit to surface, sending over our array plane, and that is it. Okay, then what we need to do is we need to begin generating our surface with these new vertices. So we'll go surface.begin, and we need to give it a mesh primitive, which is going to be mesh.primitive triangles. This is basically just the base for it. Then we'll go surface.create from, sending over our array plane and the ID of 0. Okay, so we're creating this surface now. And as well as this, since we have our vertices, so we'll have our faces pointing in different directions, okay, up, down, left, and right, we then want to also generate the normals for each of these surfaces. So we'll go surface.generate normals, and this basically calculates which direction each of the individual faces are pointing. This is for lighting and texturing, etc. And then we can pretty much go through the same process down here. So with all this here, we should then be able to press play and see that our terrain now has this jagged spike appearance. Okay, let's actually bring the camera down a bit so we can have a better look at this. Okay. And yep, as you can see, our terrain has this very jagged spike because for each of these individual vertices, we are setting it to just have a random position, okay? It's not following the noise map just yet. We'll go on that in the next lesson. But let's also have a look at mesh resolution. Right now it's set to 2, but if I bring that down to 1 and press play, you'll notice that the spikes are a lot less, okay? Whereas if I bump that up to something like 5, for example, that means each meter is going to have 5 vertices, and this is going to be very packed, and you can see how long it's actually taking to generate the mesh. So yeah, we don't want to have it this dense with vertices because, of course, that is going to take a lot more processing time. So we'll switch it back to 2. You'll see how fast it actually generates compared to before. And yeah, so in the next lesson, we are going to look at actually not having random values for our vertical position. Instead, we are going to look at how we can actually map this to that noise map. So thanks for watching, and I'll see you all then. Welcome back, everyone. In this lesson, we are going to continue on with generating our terrain by starting to actually map each of these vertices here to an individual point on our noise map, okay? So we can start getting these flowing hills rather than just a random value for the Y. So for this, we need to create a brand new function. So we're going to go down here, we're going to create a new function called getNoiseY, and it's going to have 2 parameters, an X and a Z. Now this function is also going to return a value. It's going to return a float, so we'll add in the return type as float. And basically this function, we are going to give it a coordinate, an X and a Z, and it's going to look on the noise map. It's going to find that position. It's going to then determine what the value is, and it's going to send it back to us. So what we're going to do is we're going to create a variable called value, and this is going to equal noise.getNoise2D, and we need to send over an X and a Y, so we're going to send X and Z, and then we're going to return that value. Now we can go back up to our generate function and over to the for loop where we are looping through each of our vertices. Now at the moment for each vertice we are just giving it a random position for its y-axis between 0 and 10. We don't want to do that. Instead what we're going to do is delete that line, and we are going to create a new variable called y, which is going to equal to that getNoiseY function, and we're going to send over our vertex.x and vertex.z position. Then what we can do is we can then go vertex.y equals y. And now if we save that, we should then be able to click on our terrain generation, make sure you have your fast noise light set up here, press play, and nothing really happens, okay? And the reason why is because it's a value between 0 and 1, okay? This is a terrain that is about 100 meters by 100 meters, so if it's only going up 1 meter at its highest, you know, we're not going to really see a difference. So what we're going to do for now is we're going to go down to where we have our getNoiseY function, and we're going to return value multiplied by 50. Press play again, and there we go. Okay, so we can start actually seeing our terrain now, and the material I have provided actually does automatically set it up so that if the slope angle of the terrain is greater than a certain threshold, it will turn to stone, otherwise it's grass. Okay, so we have our terrain here. We probably want to modify the noise a bit so it's not so jaggedy. So what I'm going to do is I am going to set the noise type from simplex smooth to just simplex, so it's a bit simpler, and the frequency down to 0.002. Now this is going to create a bit of a nicer looking terrain, okay, something like that. It's a bit hard to see, so let's actually then maybe bump that up a bit, so 0.03. And yeah, basically you can modify this a bit so you can see we now have these hills. It's going down to a bit of a lower area here. Okay, now let's actually go ahead and get our player in this terrain. So I'm going to delete that camera 3D node here. I'm going to open up the player controller and drag in the player scene, okay, because we want our actual player to be walking around. So I'll set their position to be 0. I'm going to drag them up in the air as well so they don't spawn under the terrain. Press play, and as you can see, we're falling down, and here we are. So now we are on our terrain, which is pretty cool. Now, if you want a different terrain, what we can do is just select our terrain generation and change the seed to a random number, something like 5, and we're going to get a different looking terrain, okay? And there we go. So now we can walk around, we can look, we can even increase the size of our terrain. So if we go to our script, up to the top, let's change the size depth and size width to be 300 now. Okay, we can probably also bring the player down a bit. Press play, and now as you can see our terrain is going to take of course longer to load up, but it is much larger and it actually looks pretty good with these hills. We have these sort of valleys here, and this is just using a single noise map to generate this sort of thing. You could go ahead and change the noise settings a bit more, changing the noise type, the frequency. You probably don't want the mountains to be this close together. You might want them to be spread apart. So for that, you would of course then decrease the frequency. But yeah, as you can see, we have our terrain. We can walk across it because if you remember, we did generate a collider for it as well. Okay. So the next lesson is going to be going over looking at how we can make this noise a bit better, okay? Because right now it's pretty simple. We have these hills and that's it. So in the next lesson, we'll look at an elevation curve. We'll also be looking at fall off towards the edges. So if you want to create an island, you could have the terrain dip down at the edges of the mesh. So thanks for watching, and I'll see you all then in the next lesson.